Good morning, good afternoon, good evening. Welcome everyone to the December 2020 monthly webinar series from phase 1. So we're just waiting for another 30 seconds to a minute until all attendees have logged in. And then we will shortly start. Okay, so let's start. Again, good morning, good afternoon, good evening, wherever you are and where you're watching this webinar. Welcome to the December 2020 webinar, and and we want to show you today a webinar which is related to UAV solutions built by our integration partner GGS from Germany using multi-sensor configuration and smart gimbal options. Let me introduce to you first today's presenter. So my name is Carsten Wieser, and I'm Integrator Sales Manager for EMEA region, and I'm based in Cologne in Germany. And today is joining me Dr. Gerhard Kemper, founder and CEO of GGS GmbH in Germany. Welcome, Gerhard.
Hello, Carsten, and hello, everybody, and nice to meet you in this showroom.
So here you can see our today's agenda. I will start with a very few corporate slides and will then hand over the presentation to Gerhard Kemper from GGS. When we have finished the webinar, we will have some time for question and answers to today's webinar topic. So if there's any question that you have during this webinar presentation, you can type in a message in the question chat box of the GoToWebinar app. And my colleague Tina Levin will taking those questions at the end and then sharing those with us, so with the audience. And Gerhard Kemper and myself will then try to answer them, try to answer them directly. So let's start with some phase 1 slides. Yeah, phase 1 is a global organization with different business units. We today see mainly something from the Geospatial department. We have a department for digitalization projects for all kinds of machine vision applications, but also where we are based on from the past professional photography. We also have the nice and well-known Capture One software for imaging, image processing of on a very high quality level. So we serve the world best leading brands with top image quality and productivity to build all kinds of products for the geospatial industry. So all the kinds of imaging products for imaging are essential and needed. To do so, we utilize, we built and designed cameras from scratch, made for this, for aerial applications. The range is starting from the IXM series camera with 50 or 100 megapixel, and also 100 megapixel achromatic sensor is available. We have the IXM RS series, which is ranging from 100 megapixel to 150 megapixel, up to two large format type cameras with 190 and 280 megapixels. These cameras can be found in a couple of applications, in a range of applications. The IXM is very small and lightweight, so it's really designed for applications. It is normally used for UAVs, and here I have some examples. For all kinds of inspection can be used, and also for photogrammetry or mapping GIS projects. The bigger cameras, bigger in size and weight, but also the sensor size is bigger. We use them in all kinds of manned aviation, also for photogrammetry products, for agriculture, oblique imagery, 3D city modeling, imaging next to Lidar, but also for inspection purpose. All this camera can be equipped with a range of lenses. For the IXM-based cameras, we have the RSM lenses, which again are very small and lightweight, but also a very high resolution and very homogenic quality across the field of view. They're ranging from 35 up to 300 millimeter. And then for the other cameras, the IXM-RS, we have a range of 23 up to 300 millimeter lenses, also ranging with very high quality, homogenic quality across the field of view. But even these can be attached to the IXM camera as well by using an adapter. The size and weight will be again then bigger, similar to the other cameras, but also, if needed, can be equipped. All lenses come with a very innovative leaf shutter system, a mechanical leaf shutter, which is very robust and fast, so up to 3 frames per second, and also 2,500 of a second, as short as exposure time, and with a minimum lifespan of 500,000 activations. Together with this fast and reliable shutter, and combined with a very modern CMOS sensors, we can provide all the time high ISO, high sensitivity, and can really use in all kinds of applications the short shutter speed to freeze the image and to have images without any kinds of motion blur. To see that here we have an example for that. It's from a manned mapping flight, and where the survey aircraft flew in one direction on its survey speed, I think something about 120 knots, and the passing aircraft also still is the passing aircraft from the opposite side is still very crisp and sharp, which shows that the motion blur is not really present. Same you can see on the helicopter example, where the rotor blades are very freezed and still perfectly sharp. Yeah, all this high resolution imagery for UAVs, I'm now showing examples from the IXM, from the small lightweight camera, can be used for all kinds of inspection tasks for UAVs, but also again for manned aviation. But here we have the examples from UAV applications. Here you see some examples for Powerline inspection. Another one here. We have an example for wind turbine blade inspection, where you can also see on the right-hand side the full image, on the left the crop and the high resolution. Another example here. We have customers who use the same camera and set up in bridge inspection, where they also can maintain to see very small defects and cracks and to inspect. For rail track inspection, we see here an example, same with a point cloud result, which can be brought out of this. And for here, a sample image from UAV mapping flights from low altitude with also very high resolution. But now I want to give the presentation over to GGS, to Dr. Gerhard Kemper, and he will show us today a bit of his product range for UAV and for multi-sensor approach, and as well for smart gimbal solutions. So welcome, Gerhard, and let's see your presentation. Yeah.
Thank you, Carsten, and welcome again to the complete audience. Okay, now I'm free. Okay, just some words about GGS. It was founded in 1988, and we have now 32 years of experience in the combination of different technologies for survey market. A lot of knowledge in the airborne market, but also since 2 years in the UAV market. So the slides are going slow.
Try again.
Yeah.
And then I click forward. Just
okay. Yeah. Yeah. What is our business is actually to create ready designed installations for the customers. So we have, of course, some the different sensors which we integrate, from Lidar, RGB sensors, 4 and 5 band, hyperspectral, corona, and Lidar. And we have also a range of UAVs, and that is actually what we today speak about. We have spread our area from Germany. We opened our branch in Izmir, and we will move to France in the next year as well. Yeah, coming back how UAV technology was used 18 years ago. I just found in my archive some images what we did 18 years on a theater in Turkey to provide images. And you see here with a helium balloon, that time we didn't have quadcopters. But when you look on the results with today's machines, so you see that still we have excellent image quality, but of course hundreds of images to capture here a centimeter accuracy that days. Today we are much faster. We have two models. Our AeroSpector S, which was launched this year with a 2 kilogram of payload, and our big baby, our AeroSpector, with a payload of 6.5 kilograms, special designed for multi-sensor configurations. Coming to the specs of the AeroSpector S, so it's a quadcopter designed as a pusher, which is more effective. So we have a motor-to-motor distance of 86 centimeters. And this gives us a take-off weight of less than 5 kilograms and a thrust of 15 kilograms. And with a payload of 1 kilogram, we can fly longer than 30 minutes, depend a bit on the temperature and the wind. And with 1.5 kilograms, for example, or 2 kilograms, we still can fly longer than 25 kilograms. That is our AeroSpector S. You see the quadcopter, you can remove the arms, easy to transport, and designed for single camera or sometimes also for dual camera setups. Our bigger baby is the AeroSpector. It has 6.5 kilograms payload. It was designed for long endurance and heavy payload flight, so we can fly longer than 40 minutes with this copter and carry 6 kilogram payloads. If we reduce the payload, we can fly longer than 1 hour because we have more place for the batteries. That's AeroSpector S. AeroSpector. Here you can see a combination of a gimbaled phase 1 camera and a Minivux laser scanner. Later on, I will show you an example out of that. Single camera applications. Yeah, so possibly you see here our extreme lightweight 2-axis gimbal for the IXM 100 equipped with 80mm lens, and this complete bundle with motors, with camera and lens, it's just a little bit more than 2 kilograms, which is, I think, the lightest combination on the market. The configurations are, for example, the IXM 100 or the RS 150 combined RGB, and we can also combine it with the thermal camera. And we have the gimbals for stabilization, and we typically use it for mapping, inspection, monitoring, surveillance, detection, and also for archaeological applications. Some examples here on railway inspection. So actually what you are looking is for very small details on the infrastructure, on the railways, but you're also looking on the next slide on images for railway applications, some reflight we did last year, and you see very crispy, sharp details in millimeter accuracy, and we are also able to generate point clouds and surface models and true orthophotos out of this kind of data. There are applications for wind park inspection, as Carsten already mentioned, to looking on the rotor blades. You see here some small damages on the rotor blade, and also to measure the curvature of a still standing rotor blade. That's one of these applications. And also applications about cultural heritage. That's an image some years ago, and also to model 3D out of this data, the objects for inspection, documentation, and also for presentation. Now I would like to jump to applications with combined sensors. Yeah, that's especially our AeroSpector, our big baby that can combine, for example, IXM RS100 and a Lidar scanner. On this image, you can see the 150 megapixel camera combined with a Regal Vux scanner or Vuxis scanner together with the Aplanix IMU. We can combine it very nicely also with thermal cameras, Corona cameras and other. And you can use it also stabilized with a gimbal or a smart gimbal solution, which I want to mention later on. Typical applications, it's wide area mapping because we have long endurance with this system, inspection tasks, especially on power lines, other monitoring tasks, and surveillance. Here, one application, we've flown a power line pole, a very interesting infrastructure. You can see this AeroSpector, which is still a quite big baby, but about 50 meters above the center part of the pole. And what we see already are here some defects on the isolators, even from a very high altitude. And what we generate out of the Lidar data is a point cloud, which you can see here in the lower image. Okay, we move on. Smart gimbal solution, that is something which is at the moment in development for our UAVs. What makes a gimbal to a smart gimbal? That's actually, it's not something very new, but it's already known from the film industry, where you want to insert a point of interest and the camera is always facing, for example, on Tour de France or something like that. So it's already known, but not in this application for inspection and this task. A normal gimbal with 2 or 3 axes compensates the movement on the aircraft and can be oriented to the specific point of view or specific angle. That it's already something which is on the market and what is also our gimbals already done in the past. But monitoring power lines in an offset flight, you want to receive typically forward and backward and sideward view to the infrastructure. And this either means that you have to insert more cameras in forward and backward view, or if you want to save the cameras and payload, you try to insert a gimbal that assists to keep the relevant infrastructure in view. So you can see on the image below, it's a flight path, and you see that the camera is concentrating on the poles, and in between the poles, the camera is moving to the side to capture the rope, and then slightly moving forward to capture the next pole. So you have here forward, sideward, and backward view to the infrastructure. And that's a quite interesting feature. On the next slide, we also can see that this one is 3-dimensional. So if you have a flight in hilly terrain, so typically when you look forward or slightly oblique, you have to view forward a bit up with the camera. And when you descend, you have to watch down. And you see here on the flight path that also in the 3rd axis, you have to move the camera, that you have the objects in view and that you don't capture images which are not needed. What do you need for such a gimbal? So first of all, the gimbal itself. At the moment, we are using brushless motors with a specific controllers to compensate the Z-axis and pitch, or better, all 3 axes. But with the Z-axis and pitch, you already can done the most of these features. You need an IMU, so have the information how to stabilize the flight movements. That's the classical part of the gimbal. And at least the list of the points of interest with 3D coordinate, it means 3-dimensional coordinates, at least main and sub POEs to give, let's say, the flight controller the information where to move the gimbal, where to put the view, and that it goes smooth and without creation of additional forward motion blur. The calculation of the distance, that's something what you can do by the difference of the point of interest and your actual position, which you achieve from the GPS. And also in respect of the time to the next POE, the distance, and you can move the gimbal in such a speed that you don't create an additional forward motion blur. Next slide, please. That's our new baby. That's designed with 2 phase 1 cameras to have, let's say, the entire pole in one, let's say, double image, because typically you can't capture when you want to have, for example, a 2mm GSD, this with a single image. So you have the upper part and the lower part of the pole. And if you, in that case, It's coming out of a project which we are running together with Siemens, Fraunhofer, Schiebel, and other partners. We also want to have high resolution thermal images. So we have inserted here 4 thermal cameras to have the entire pole captured with RGB in high resolution and also with a high resolution in the thermal cameras. This is our 3-axis gimbal, and we are waiting, let's say, to have it finalized to fly, hopefully this year with this gimbal, to show that everything is moving and capturing the right direction. Okay, what we have in additional UAV applications. So here we are working on a system that's designed for disaster management with live stream of thermal and RGB images, for example, for wildfire detection and to download the data via 5G network for the disaster management teams. That's an upcoming project in Saxonia. We have launched our methane sensor, which is flying over a dump site, for example, and it's looking for leakage in the dump site or for other environmental critical stuff. It can be carried by the AeroSpector, for example, also together with the thermal and the RGB camera. Additional UAV applications, we want to start our business also in Namibia, and here we have, of course, some very specific tasks. It's the mapping. Everything is more or less wide area mapping, nature protection, infrastructure monitoring, irrigation planning, agriculture, and many other applications, and especially in countries like Namibia, which are far, which are remote. The UAV technology still is, let's say, affordable price-wise, and I think it's a good entrance level to assist here to cover the needs and to assist also the people there to develop their country in the right way and save the nature. Outlook and further research projects, what we are working on. At the moment, we are just working on a smaller and more smart corona camera, which combines UAV and RGB for powerline monitoring using PTP synchronization. We are discussing about UAV swarm for infrastructure monitoring or wildfire detection, which gives us different views of the different UAVs, and applications for bigger and long-range UAVs like the Swiss drones, which was equipped with 3 thermal and 3 phase 1 cameras and can be optional equipped with corona and Lidar sensors. Summary. What is the situation today? UAVs are more and more useful for specific tasks, especially when we need ultra high resolution, for example, on power lines or infrastructure, when we speak about millimeter resolution, which can't be carried from the ground or can't be managed from aircraft that easy. Smaller and lighter sensors in combination with more powerful UAVs widen the range of applications, so we can combine sensors, we can fly longer, which definitely gives more space for applications. Flight time is still an issue, so for long distances, the use of wing-based UAVs is, let's say, in focus, and they can fly more than 1 hour and can reach even more than 100 kilometers. But that conflicts, of course, with ultra high resolution, because we are then focused with forward motion blur. It can't stand in the air. The regulations continue to be a difficult issue. It's still not harmonized. It's going on the European market with SORA, but it's still very restricted and still a lot of communication and legalization process has to be done. Communication and redundant technology may enable soon BVLOS flights. It means beyond flight beyond visual line of sight missions, which is at the moment still forbidden. And innovative data analysis methods like AI will handle the data faster, more precise, and automatically. So we capture more and more data volume, and it's needed, and we also try to work on that in the future, how to deal with the data in a smart and fast and more automatic way.
Okay, thank you, Gerhard. So now we are already at the end of Gerhard's presentation, and we have some time for question and answers. Yeah, I want to ask Tina, our colleague, if she has already got some questions during the presentation.
Yes, hello everyone. We have received some questions already, so thanks Gerhard and thanks Carsten first of all for the presentation. But I also want to invite the audience again to ask any questions. If you have anything, just type them into the box and I will read them out for you. So we've got like several questions already, and I just start with question 1, which is focusing on the smart gimbal, asking what needs to be prepared to enable smart gimbal to follow, trace each point of interest during the mission.
The first thing is that you of course have to have let's say the point of interest in 3 dimensions. So you want to know where to look to, and of course you need your actual position in 3 dimensions. So with these 2 informations, you already know where you are and where you want to look to. And then you need, of course, also information about the camera, the opening angle, and also limits from which distance you want to observe the object and when you want to move to the next object. So some kind of hysteresis between the points of interest. There are several parameters, and we are still, let's say, thinking what is a good solution to also in respect to the flight speed and the density of points of interest.
Okay, thank you. Just to let the audience know, because this is a question that's coming up just now, is like whether this presentation will be recorded, and yes, it will. So what we're going to do is we have recorded the presentation, and it will be available on demand later, and you will also get an email with the link to the on-demand video on our YouTube channel. Another question is, what softwares do you use for studying the images?
At the moment, in-house, we do our normal, let's say, image processing pipeline with Skyline, Argisoft, and some other tools. At the moment, we are not, let's say, in the service active. So we are, let's say, a system integrator and developer. But there are many partners who are working on AI. For example, also Siemens are working on AI technologies for their service to automatically detect and analyze the images.
Okay, thank you. Another question, are your cameras designed for any particular make of UAV or drone, or is it easy to host in general UAV and drones?
At the moment, we are linked to our UAVs with our controllers for a smart gimbal. However, the normal gimbal can be also adjusted to any other type of UAVs that are fitted with a controller. At least the gimbal itself has its own controller for stabilization. It works, let's say, more or less standalone with power, but the smart gimbal at the moment is linked only to our machines at the moment, but will be adjusted also for other drones and other also aerial applications as well.
Let me also add some remarks here. So the phase 1 cameras can be integrated easily into multiple kinds of drones, and they also are already integrated by a lot of drone manufacturers. And the IXM 100 or IXM 50, the small ones, are very made for that to ensure the medium format image quality and to have it into a lightweight and small, relatively small camera for UAV applications.
Okay, thank you. Next question, what vibration reduction systems are needed for large helicopter UAV and phase 1 cameras?
We use different type of bumpers, which we we analyze, first of all, the vibration which comes from the aircraft or from the UAV, and then it's also related to the sensor payload. So as higher the payload is, as easier you can compensate the vibrations. So we have different wire-based vibration dampers, which we adjust to the related payload and the aircraft.
Okay. How do you refocus the lens during the flight? To use a kind of autofocus or a rangefinder?
No, at the moment we are working to using the SDK from phase 1 to refocus the lens, because with a smart gimbal, or at least with the point of interest, we know where the point is and where we actually are. So we refocus by calculating the distance and apply this distance to focus the lens. So there's no autofocus, and at the moment we don't have rangefinders. It's an idea to use, for example, Lidar or a distance meter, but at the moment we do that just on the difference of the calculated and the target position.
I also can add that autofocus always has a limitation because it measures mainly contrast, and depending on the situation, it might go wrong. And the method which GGS here is using by calculating the value between the actual position and the point of interest is a very accurate solution.
It's actually the most reliable, especially for power lines.
Can the smart gimbal also be integrated with other UAVs or even with manned helicopters?
It's foreseen, but typically for helicopters we have a bigger payload, so we would not work with the brushless motors. So we would use, I think in that case, stepper motors or other motors. It's not yet ready, but it's on the plan that we develop it in that direction.
For what kind of projects you have designed the AeroSpector to be used with Lidar and phase 1 cameras? What's the benefits with the combination of Lidar and high-res cameras compared to using them as a standalone?
Yeah, the combination, first of all, saves flight time. And typically for Powerline inspection, at least the combination of RGB camera and Lidar typically is used to merge the images to have the 3D structure of the data. It's typically also on one side a mapping issue of the power line to measure also the wires, the hang through of the wires, to get this information, which you typically get from Lidar. And from Lidar you also get the information about the vegetation that comes too close, because you have the first and last poles. This is difficult to see on the RGB images. But on the RGB images, you see very nicely some defects. You have the high resolution information, which the Lidar cannot provide. And in combination, for example, with thermal or ultraviolet cameras, with ultraviolet, you're looking for discharges. So you can see where, let's say, a failure will pop up. And this one can help later on to analyze this big data to look on the specific area. That's actually the main focus of the AeroSpector, to carry at least 2 or 3 sensors for power line monitoring. But of course, it can be used for other applications as well. And to have, let's say, the information captured in the same time, instead of to flight, it also gives, for example, when you do some wildlife monitoring with animals, when you fly the second time, the rhino might have moved. So to capture him with thermal and RGB, I think it's wise to do it in a combination.
Okay, thank you. I've got one more question. So again, to the audience, if you have any questions, just ask them now. The next question is, how long will be the flight time at 3,000 meters above sea level with AeroSpector and AeroSpector S with 2 kilogram payload?
I can't tell you in figures, but it will be definitely shorter. It depends on the temperature, but of course the air pressure is lower, so we need more energy to fly. So I think it will be about 20% less on 3,000 meters. but I can't tell exact figures. It's just an estimation.
Thank you. So yes, that's the last question that was asked so far.
Okay.
Yeah.
And if there's no further question, yeah.
Hang on, we just got a question. It's like, is phase one camera mounted on gimbal and the same as Lidar? How do you deal with IMU data if not all sensors are moving in the same direction?
So in that case, we have to have, let's say, 2 IMUs on the one on the Lidar sensor, which is typically not gimbaled, and one on the phase one camera in addition, which is on a gimbal. We of course have incremental sensors on the gimbal. We know how far it has moved, but that is not that accurate as a very precise IMU. So everything depends a bit on the precision of the IMU we want to have. With the images, we still have, let's say, the chance, because it's a frame, to merge them with some tools to get more precise post-processing of the images, the orientation. With Lidar, we have to rely on a very precise IMU. But definitely, if we want to have direct referencing and we use a gimbal, we need 2 IMUs.
Okay, thank you. Yeah, that's the last question we had. So I pass back to Carsten.
Okay, yes, yeah. So thanks to all the viewers for joining the webinar. Looking forward to see you again at the next webinar. Like Tina already mentioned, and like always, the webinar is recorded and will be provided here within the next 2 or 3 days on our website. So you can go back and view it again, or reference it to someone you know and that also would like to see that. Thank you again for joining our webinar, and have yourself a wonderful and great day.
Carsten, can I interrupt you? Because I just got a final question in, and I think
yes.
we should give a chance to answer that. What is the optimal speed to capture the best images?
Do you want to answer, Carsten? The best
I think
speed,
it depends on the resolution level you're chasing for, or you want to see. So for sure, if the higher resolution, the slower you need to fly. So to get you an example, if you go for 1 millimeter accuracy, then you're not allowed to fly faster than 3 meters per second, because otherwise you will have some motion blur. Yeah. So it depends on the resolution. If you go to 2 millimeters, you already can, not really fly double the speed, but nearly double the speed. So it depends on the resolution level you're looking for, and as well also to the weather conditions. So if you have very bright sky, you can normally fly a bit faster and use a shorter shutter speed. If you have very poor weather conditions and fully clouded, fully covered clouds, you also need to take this into account to set the correct speed for flying. Okay, so, but if there's any further questions, you'll also be welcome to email us so that we can take this offline and give you an answer then. Yeah. Okay, good. So thanks once more and for joining, and have yourself a great day.
Okay,
all the best.
Thank you, Carsten. Have a nice day.
Thank you, Gerhard.
Bye-bye.